The makeup of matter. The purpose of this keynote is for us to take a look at what atoms are and to distinguish between atoms and what's commonly called elements. So one of the things we'll look at is what is the relationship, or how are atoms and elements related. Another very important part of understanding the makeup of matter is to understand what a molecule is. So what is a molecule, and how is an atom and a molecule related? A fourth term or concept is compound. So another purpose to this is for you to understand the relationship between a molecule and a compound, and obviously the relationship between an element and a compound. But the center of focus, really, of our study for the next couple of months is going to be the atom. That right there. So let's take the atom first. Here is a picture of a diamond. And a diamond is a type of substance that's a pure substance, meaning it's only made up of one type of atom, or one type of thing, or particle. And there it is. Obviously, it has to be enlarged for you to see that, but let's say that that little white circle is the smallest particle of that diamond, which we would call an atom. So let me enlarge it there for you so you can see it a little bit better. So one of the ways in which we can define an atom is that it's the smallest particle of any type of matter. It's the smallest particle of all matter. Should be simple enough to understand. So how is it related to elements? Well, the best way I can show you how they're related is for you to see again that white circle there represents an atom. And if that's an atom, then this is an element. So one way in which we can define an element is that it's the simplest type of pure substance. And once again, a pure substance is something that only contains one type of particle. And you can see from that picture there of an element that all of the atoms are the same. Another way in which you can define an element is any substance that cannot be broken down into a different or into another substance. So as you see, I have just broken off a piece of that element. It's still that same element, isn't it? And you can tell that because it's made up of the same types of atoms, those white atoms there. I could even break it down even further. That's still an element, isn't it? Because the only thing that makes it up is that same pure substance, that same atom. So another way in which you can define an atom is that it is the smallest particle of an element that has all the properties of that element, all the physical and chemical properties of that one small atom on the right has all the same properties as the rest of the element over on the left side of the screen. So an atom is the smallest particle of all matter. It can also be defined as the smallest particle of an element that has all the properties of that element. That phrase, that has all the properties of that element, is a key phrase there. So here are a few questions that will help clarify in your mind, hopefully, the similarities and differences between atoms and elements. The first question is, are elements made up of atoms? Well, here are the elements that we just saw in the last slide. Is this element made up of atoms? Well, obviously yes, because there's the atom. So yes, elements are made up of atoms. How many different types of elements exist? Well, the way to discover this is to look at a periodic table of the elements. And for every block that you see there, or every tile that we call section of this periodic table of the element, or tile of a periodic table of the elements, represents a different element. This is not quite the most current periodic table of the elements. we have somewhere in the neighborhood of 116 or 117 different types of elements that exist in our world. How many different types of atoms exist? How many different types of atoms exist? Well, to answer that question, you look at the same chart, because not only does each tile or each box on this chart represent elements, they also represent different types of atoms. So, for example, you have the element hydrogen and helium in that first row. There are also different types of atoms. So, the question, are the terms atoms and elements interchangeable? Do they mean basically the same thing? The answer to that is yes. But you have to remember that atoms are actually the smallest component of that element. That brings us to molecules. Here is a picture of a cube of ice, obviously melting. Now, ice is, as you probably know, is H2O. So we can say that it's a molecule or compound. So to understand this, let me show you one of those molecules. And so let's say that that represents a molecule of that ice or of water. Let me enlarge that for you so you can see that. That's actually not really a molecule of water, but it is a molecule. So a molecule can be defined as two or more atoms that have chemically combined. Not just combined, but chemically combined. And at this point, I don't expect you to know what chemically combined actually means. But hopefully from that picture, you can kind of see that the atoms have joined each other. So there's a molecule. What's the relationship between a molecule and a compound? Well, the best way to do that is to, again, direct your attention to that molecule there. If that's a molecule, then the compound is this. So the relationship that we saw between atoms and elements is the same exact relationship that we see between molecules and compounds. So one of the definitions of a compound can be a substance made up of two or more elements chemically combined. Boy, that sure sounds like the same definition, or almost the same definition, as the definition for a molecule. Two or more atoms chemically combined is a molecule. Two or more elements chemically combined is a compound. So I could break this compound down into something smaller, like I did just there. Is that still that same compound? Well, of course it is, because it's made up of the same kind of molecules. And I could even break it down into its individual molecule. So, like we did with atoms, we can also say that molecules are the smallest component of a compound, and here's that key phrase again, that has the same properties of that compound. That molecule that you see there on the right has the same properties, such as density, boiling point, freezing point, melting point. Whatever physical or chemical property you want to talk about or want to insert there, that molecule has this very same chemical and physical properties of the compound that you see left over on the left-hand side of the screen. So here are some clarifying questions to help you understand even further the similarities and differences between molecules and compounds. Are compounds made up of molecules? Well, there's that compound that we saw on the previous page. And if we remove one of those, the smallest component of it, yes, that's a molecule. So compounds definitely are made up of molecules. Are the terms molecules and compounds interchangeable? Yes, they are, just like atoms and elements are. Molecules and compounds can be used interchangeably. But remember, molecules is the smallest component of a compound that still has the same properties of that compound. Are compounds made up of atoms? Well, let's take a look at that. There's a